Hello and welcome to another episode of building a Flutter game that will be multiplayer without any libraries except using libraries on the server. We just talked about in the previous episode about all these terms and what they mean and how we can use them. And actually, I'm going to get my notes for a second, because what I did is I thought about how can we actually apply this to our game. So what I thought about is this. Simulating the basically predicting our opponents and ourselves is not a huge problem, right? Basically, our UFOs, they don't change direction that often. So maybe I should actually launch the game to show what we're actually talking about. So let me go to that game, and I'm just going to launch it. I'm going to actually launch an older version that I did before, just for demonstration purposes, right? So while this is launching, I keep talking about why this is actually easier for us. Because basically, we can't just go left and right in our game. All we can do is we can change the rotation of where we're pointing at, and then we can accelerate. So we can change the angle and can apply thrust, and then we can shoot. And that's pretty much all we can do, right? So what that means is that if we have an opponent, so obviously ourselves, so let's just rename this to ourselves. Okay, so here we get the point. So now I'm actually going to show this, right? So we can rotate, right? But we can't move left and right. So if I move left and right, that's basically the same as rotating, right? So there's no way to move left or right. What we can do then is when we rotate it, we can then accelerate. So now we just changed our velocity, but you can see it's very predictable, right? I can tell you exactly where I'm going to be in a little bit. I'm going to be here, right? It's very predictable. Unless I change direction, but I can't just easily do that. I have to actually rotate first and then accelerate this way, right? So the thing is, what I was thinking is, instead of sending every key that I'm pressing, and I can shoot, right? But you can see that here I already limited the amount of bullets I can fire in a certain amount of time frame, right? So what I want to do is this. I don't actually want to send every key. That's not really necessary. What we can do is we can just process our key, and wherever we rotate it to, we send that to the server, right? But we basically already rotating on the client as well before we get the server update, right? And then what we can do, every time we apply thrust, we send our updated velocity to the server, right? So, and we don't apply thrust that much. And what we'll actually do is we'll actually limit the amount of times that we can apply thrust, right? So I can't do this. Now I can, but we'll change that, right? So and you can see I'm hitting walls left and right because I hit a crazy velocity now. But basically, we'll say you can only apply thrust every so often. Maybe however long this animation is, right? So until the animation is over, we cannot apply thrust. So that limits us maybe every second we can apply thrust once, right? And it makes sense, right? Maybe our ship is like that. We can't just say go crazy and just apply thrust however we want to. We actually, have to, maybe the engine in our ship has to get ready to apply thrust again. The same with the shooting. We cannot shoot willy-nilly. Maybe we'll, there's a certain limit to that as well. However, the rotation is fine. But the thing is, the rotation, we will not send every time the rotation just changes slightly. We will basically only send regularly the update of the rotation, because the thing is that we don't necessarily have to see in real time into which direction our opponents are facing. If you get it a little later, that's fine, right? We don't have to worry about that. So that's basically what I want to do. So basically, I'm gonna put this here. Strategies to apply player techniques to our game, right? Looks like okay. Okay, so how can we apply this? And I'm gonna put this a little like this so people can see better. So what we're gonna do is first, what's the main strategy we're gonna use, right? Main strategy. So what I want to do is I want to use basically a combination. So we're gonna have an authoritative server sending updates every 100 milliseconds, right? So that's what we want to do. Then client updates are limited to 100 milliseconds, or like 10 per second, right? Let's say that. Okay, so that's what we want to do. Client side prediction is used to extrapolate opponent's position from previous position and their velocity. Then so basically that means like we don't need to get updates about the opponents all the time, and basically so therefore like getting updates 100 milliseconds every 100 milliseconds is fine. Basically the right, so basically we're gonna put another thing here. Okay, so we're limiting player inputs. So what we'll do is we basically limit the or basically require 100 milliseconds between each shot, right? And instead of sending a key press, we send something like player shot, right? And we give the angle at which the player shot, right? So basically, if I'm facing this way, right, and I shoot, now the server should know, okay, the player was facing this angle, was at this position, and I think I will send the position along as well, but no, but we can't do that, right? You can't trust the player. So we could think, okay, why don't we just send the position as well? Well, because now if I hack the client, I can say I'm here and I'm shooting this way and now I'm hitting my opponent, right? We don't want to allow that. So we only allow the angle of where I'm facing, right? Then basically, instead of sending rotation, right, input, we send updated angle, and we give it the angle. So now the server can still basically, if our opponents kind of rotate, right, we don't see it. Like if the opponent does this crazy thing, we don't see that, and we don't have to see that. But once the opponent rotated and then left it for a while, we eventually see where the opponent is facing, right? And then basically, and instead of sending, oh no, so basically, right. So this has nothing to do with the shot. And then also what we do is we require 100 milliseconds between each thrust, right? And then instead of sending thrust, we send, oh no, actually sending a key, right? We send, we basically send thrust, something like this, applied thrust, and we give the angle, right? So now basically we can say, okay, the player was facing this way, and then apply thrust. And then the server can then increase velocity, right? Server then calculates. Okay, so basically by doing that, we already limit the changes that the server can receive to like 10 per second, which is good, right? So that also means, and maybe like player shot, we can also rename that maybe to bullet created, right? Because that's really what's happening. We don't even care. We don't really care like even who did it, right? Like there's now a bullet, and it's facing this angle, so we need to calculate the velocity of the bullet from the angle we're given and put it in the game. And then from then on, the bullets are basically calculated on the server, right? So other players and bullets are simulated, are predicted on the client, right? And velocity, same server are used, which allows us to predict collisions client side as well, right? So we can even like so we can see sorry, I'm trying to be in the game. So basically we can see that we're already doing this client side, right? Now the thing is that the server will also handle these collisions client side, but on the client server side, but on the client we can already hit if we're not going to fly through the wall, right? And then finally get the update that, or actually be bounced off the wall, right? So we don't have the problem because we're using the same controllers. And then basically we're going to use a dead reckoning to correct client predictions for now. And we do the both for the opponents and bullets, as well as our own player, right? So that's something that I'll think of, because there are two options here, right? So because if we simulate, if we basically limit ourselves to this, we basically make our lives a lot easier. And it could be is this correct? Authority. So if you do it like this, we're making our lives a lot easier, and it could basically be argued that that's just like how our game works, right? So let's see what else I had here. So the other thing is there's another option that we could do is instead of we can omit bullet positions. Instead, rely on client prediction and then basically use server report exploded bullets. Right, so basically instead of having this huge, so basically we explode bullets, created bullets, right? Created bullets. So what could happen is, we fire a bullet, right? But instead of the server sending us all the updates of the movement of the bullet, it just sends us a bullet was created. I mean, if we shot it, we know that already, but the server will still tell us that. But obviously, if another player is creating a bullet, we need to also show it. So it says as bullet is created. And basically what it says, so that would basically look something like this. Created bullet, the same way. But what we're going to do there is we're going to already give it the velocity. And we're going to give it the position and the velocity. And now the client client predicts positions, right? And then we can send exploded bullets, where basically we're saying that and then we give it the position, and so now the client can render an exploded bullet in the position. There's one problem. We need to actually know which bullet exploded on the client, right? So we're showing we created a bullet, but and then one exploded, but we don't know which one, right? So what we can do though is we can set an ID, and we set that here as well. So now the client could know, okay, the bullet that I was showing here and here, it actually now explodes. So in the worst case, if the prediction is totally wrong, we're shooting a bullet this way and then suddenly explode here. But I don't think that will happen a lot, because once we give it the position and velocity, that's pretty much all the client should need to predict. Obviously, the client can already see a collision of a bullet and maybe already render an explosion. But that's another. So that's just to get smaller packets to be sent. Right? Because we might have, you can see if I'm shooting around, right, I have a bunch of bullets flying. That's just me, right? Alternative is basically to limit the amount of bullets. Or basically the ammo available, right? So we cannot just willy-nilly shoot like crazy. We actually are limited in that. So let me read through this. So you already know how to limit the frequency of client actions, right? To basically match the server tick interval. So that's good. And the thrust. Okay. So the other thing is, server processing of ticks, of basically player inputs. So basically there are two options, right? One is we can delay effect until server tick, right? We can delay the effect of or we can delay execution of the action, right, until the server ticks. So that means like I'm shooting now, right? Boom, I shoot. But the thing is, the server doesn't immediately, when I send it, hey, I shot, it doesn't immediately process that. What it does instead, it waits till the next tick, and then processes my action. However, if I do it really quickly, so the thing is, like, I give it the angle, right? So in the worst case, what could happen, I shoot, and in my simulation, my bullet is already here, but the server starts processing it later, so the bullet is actually now here, right? But since it has the position and the velocity, it will always fly in the right direction. It just may be delayed, right? So that means in the worst case, bullet is trailing client side prediction by 100 milliseconds, right? Because if I just shoot and a server gets my input, and it just happened to be it just processed its own input, then we basically we have to wait 100 milliseconds. Now the thing is that the client also has its own 100 milliseconds tick, right? For inputs. We already mentioned that. So we have to make sure that we don't suddenly like have these weird things where some clients got lucky and are closer to the server, and their actions get executed more close to the actual time, and others. So what I'm trying to say is like we're saying that basically our clients only can shoot every 100 milliseconds, right? So if let's say the server ticks at 100 and 200, right? And we happen to start up the client to where we tick at 150, 250. That means when we send the command, then there's roughly a 50 millisecond delay, right? But now if we tick at 101 and 201, once we send it, then we are always just after the tick of the server. So we need to see if there's a way, find a way to align client input ticks to server ticks, right? So, but that should be fairly simple. And that's the one that we want to use. There are other ways, but that makes it all more complicated. So basically, just to finish this off here, the change of angle happens in real time, but is reported to the server at a 100 millisecond interval, even if no other client action occurred, right? So now we limited our messages sent to the server to 10 per second, which is a good thing. But the thing is, on the client, we should not see a delay at all. We will see this change right away. When we apply thrust, we immediately predict where we're going to go, and then the server will basically correct our position a little bit. We might jump back, right? We might jump back a little bit or something. We might be a little off, but we actually have to see. We actually have to see how far we get off, right? So what I want to say here. To be seen or whatever, right? Is you test how well that reckoning works for our game, and try the following. If we end up with lots of player jumps, right? Basically position jumps mostly. So what we can do is we have at our disposal, we can use interpolation. I don't want to do that though. What we could do is we could like apply smoothing, and we haven't like to correct position slowly over time, and that would be the number one choice, or in worst case I don't want to use interpolation until I really have to, because that now suddenly we may need lag compensation and all these things. It's way more complicated like that. So what I'm going to do is I'm actually going to look at through our documents if we can find something about smoothing. And I think I may have found that in here. We'll just search through this. So basically we will put this here. This actually has to do with dead reckoning, right? So, or it's related to some, so we're going to put it here. So smoothing, basically what that means is instead of correcting client position to position sent by server in one, or let's just say correcting client position in one step may lead to jumps, right? And so what we can do is instead we can correct position slowly over time in to make it look smoother, right? That's where smoothing comes from. So let's do another one. I think there was another one that talked about it in a little better way. Here. Let's see if this is maybe talking about smoothing as well. So yeah, if you use interpolation, right, this is not really necessary. Oh, it's just called the entity. Okay, so basically we don't need to do that in order if we do interpolation, because if it's working properly, we already know ahead of time where we're moving that player. The client, the server already has told us, right? So we don't have to do much smoothing there. There's something different. I think here was another interesting one. And I'm going to put all these resources again. I'm going to put these all as part of this devlog. So he basically had some interesting, and actually I'm going to go to this website so we can look at a little bit at the different approaches to smoothing. Let's see if I can just go there now. Nope. It didn't copy it. It gave me all kinds of options here, but I just wanted to copy it. All right. So, all right. What? I have it here also. So let me try to find it here. I thought I did anyways. It seems like we're missing part of the link. Okay, I don't know where the 7.7 came from. Maybe the date or something. So we basically, you can see here, here's some real good animations. So so without smoothing, so I think this is like this is on the server and the right is on the client or something like that. It's not explaining which one is which, but I think the left one is like the one on the server, and like the right one is on the client. I don't see like, but now we basically have a smaller bandwidth. Now we can actually see problems. So this was like a really high bandwidth. We can start seeing that this looks over here looks a little bit janky, right? It doesn't look quite as smooth. And so when we do apply smoothing, it kind of looks okay again. So basically, he's talking about smoothing here. And he's simulating a lot of blocks, so it's way more complicated to apply smoothing there. But basically, he's using some way to say, okay, let's just say my block here, right? This block is, in my extrapolation, or in my the way the last update I had, it was here, and now I kind of predicted that it would be here, and it would be kind of rotated in a certain way, but maybe my physics engine on the client is not quite as detailed as the one on the server. So now suddenly the server tells me, well, your block is actually rotated a little more like this, and it's actually a little more over here. So instead of jumping that block and like changing it like that, he basically says, okay, I have a formula to say slowly but surely I'm going to narrow it to the server position, and he obviously gets more and more updates and keeps applying the same formula. But so instead of the it jumping like crazy, it basically gets there slowly, right? By the way, here's another one that we could put here: deterministic lockstep. So I'm going to put that as well as a resource here. Just collect everything we can. So that's the one that we talked about earlier that Doom was using, that only really works on LANs, right? Okay. I think at this point we pretty much covered most of what I wanted to cover. So I don't want to drag this out unnecessarily. So here we have some more on snapshot interpolation. This is a nice one. There are different interpolation algorithms actually. He's talking about this in a little more detail. So again, this will be part of the resources. All the documents you see here. Oh, by the way, I didn't even go into this at all. So, right. So this is another great one that I went through, which talks about all these things in really great detail. And I thought I made some notes. Yeah, some here. Talks about interpolation, extrapolation. So if you want to read more on this, I highly recommend this as well. Again, I will put the these ones here in an order that I recommend reading them. And maybe what I'll do here is I'll also sort this by Gaffer on Games and so on, right? So we can have different ones. So there will be Valve software, right? So we have Valve. And then this is the series that I recommend, and this is also Valve. So just put this like this. Okay, so now we got some good resources. I think at this point, instead of going through these documents as well, pretty much everything that I found in there is already we already have covered here. But obviously, if you want to read more up on this, you can. But the main point of this was to explain a little bit what all exists, what options we have, what strategies people use, and then we came up with our own strategy for our game. And this is why we have to be seen here, because our assumption of how things work may be wrong. So what we're going to do is we're also going to simulate server lag. We need to somehow find a way, because I'm working right from my machine. Obviously, the connection is very fast. We need to somehow find a way to simulate slow network, basically higher latency and so on, and see if our strategy works really well, or if we get a lot of basically jumps and so on. If you don't, then our strategy will be applied. Otherwise, we'll find a different way. So in the next episode, we'll actually go ahead and apply these. However, before that, I will stream cleaning up the code. I will not make that an episode because it's not going to be fun. We have to refactor the code, however, because it got a little bit unclean. So just to show what we have so far, well, actually, I'll do that next episode. So forget about that. But yeah, if you want to see me clean up code, join me in about 2 hours and 15 minutes at 9 p.m. Eastern. I'll probably be going for 2 hours cleaning up code. So then we can have some nicer episodes again to clean with a clean slate and actually apply these ideas we have to our game and see how it works with multiplayer. So this ends the stream. If there are any questions, we can take a little time now. So if anyone has a question, I'm going to give it like a minute or so. If I have no questions, I'm just going to sign off. But I want to give you a chance to ask questions. Oh, what I'm going to do while we're waiting, if someone asks a question, I'm going to post a website in here. So in that website, I have all the information about the game, and I will create a devlog tab here with all this. This is Markdown, but I will find a way to render this nicely into kind of a web page kind of thing, and all this information will be available, including all the resources. Okay, and yeah, if you're interested in this, obviously follow me on here on Twitch. You can also follow me on Twitter. My TH Lawrence is my Twitter handle. Should appear down here. So make sure to follow me if you want to hear about the next episodes that I'm doing. There's also a playlist, obviously, which is listed here on this page. So you can subscribe on YouTube. All this is there. So make sure to go there. Otherwise, if there are no further questions, I will sign off. Thank you very much for watching. And if you want to join me for cleaning up code, and by the way, I'm streaming every day 9 p.m. Eastern. And so tomorrow, after cleaning up today, tomorrow we will actually get into applying these strategies. Well, thank you for watching, and I'll see you next time.